This question is about reaction mechanisms. Part A. Chemists use curly arrows in reaction mechanisms. Part 1. What does a curly arrow show in a reaction mechanism? The definition of a curly arrow is what we're asked in this question, and it's something you need to know for this specification. A curly arrow is the movement of an electron pair. So to get the mark for this question, you get a mark for saying movement of an electron pair. Part 2. Draw structures to show the products in the reaction mechanism below. So this reaction mechanism, we're going to produce H2O or water, and then that would leave us with the structure with a positive charge where we have our H2O. So to get the marks for this question, you get a mark for having the correct carbon skeleton and a mark for having the positive charge on the correct place on the carbon skeleton. Part 3. Use the mechanism in Part 2 to explain what is meant by heterolytic fission. For this question, you need to dissect heterolytic fission, and that means we're going to define heterolytic and then fission. Defining heterolytic, that would be when one atom receives both electrons. Then defining fission, fission is the breaking of a covalent bond. To get the 2 marks for this question, you get a mark for defining heterolytic, so saying that one atom receives both electrons, and a mark for defining fission, which is the breaking of a covalent bond. Part B. An incomplete reaction mechanism is shown below. Part 1. Complete the mechanism by adding curly arrows and any missing species. Before drawing any curly arrows, we need to look at the intermediate. So on the intermediate, we get rid of our carbon double bond oxygen, and it's replaced with a negative oxygen, and the OH minus has bonded to the carbon. So drawing curly arrows to reflect this, we would have a curly arrow from the centre of the lone pair on the OH to our carbon. This would bond it to the carbon. And then we would have a curly arrow from the carbon double bond oxygen to the oxygen, and this would produce our O minus charge. Then looking at our product, which will help with the curly arrows in our intermediate. In the product we have no Cl, so that means we're going to produce Cl minus. In order to do this, we would have a curly arrow from the carbon Cl bond to the Cl, and we've reformed our carbon double bond oxygen, so we need a curly arrow from the centre of the oxygen to the carbon, and that would reform our carbon double bond oxygen. For this question, you get a mark for the curly arrows in your reagent, so each curly arrow in your reagent gets a mark. Then you get a mark for the curly arrow in your intermediate going from the lone pair on the O minus to the carbon, and then you get 1 mark for having the curly arrow from the carbon to the chlorine and writing that this would produce Cl minus. Part 2. What is the role of OH minus in this mechanism? The role of OH minus, well, it acts as a nucleophile in this mechanism. So to get the mark for this part, you need to write nucleophile on the answer lines provided.